Hey guys, so I'm going to be discussing a topic today that's a term that you will hear a lot when you watch lots of cubing videos and just cubing tutorials, and that is slow turning. So what exactly is slow turning for? Um, First, slow turning is for if you're new to look ahead and you want to have an easier view of the cube, get more into the cube, but you don't want to be overwhelmed by turning fast, and also not being able to see the pieces at the same time. So if you turn slower, then we already see this edge here, insert it, and if we looked ahead, we see that this edge has red here and it's free. And then from here, we should look ahead into the PLL. So we see this a block here, which means that we'll have to do a J-perm. And slow turning is actually faster than fast turning if you're around the 15 to 20 second level. And that's mainly because solving an F2L case, like something like that, it actually takes a lot of time to look and recognize the case and then execute it really quickly. And basically what I'm saying is it's faster to already look at it when you're solving a different one than get into it slowly, and that's just how you can solve it really quickly. And that's basically what slow turning is for. Now I'll do a slow turning example solve, and I'll show you what I'm thinking of when I do the slow turns. So here, this isn't aligned properly. And basically what I'm thinking in a slow turning solve is I'm already looking at what I'm going to solve next as I'm solving it. So now we do soon and a GA perm. But anyways, if you saw the F2L almost had no pauses. And if you don't have any pauses, it's actually faster than doing something like this. So I'll do a solve where I recognize it, then abruptly, so I abruptly recognize it, and then I just go into the case. So cross should be smooth, but like something, and then look for a long time. And that's not what you should be doing. So you shouldn't be taking lots of time to analyze this, because as you're solving a different pair, you should have analyzed it prematurely. So if I was doing slow turning, I'd already know what to do. But for example, if I had this case, if I did fast turning, I'd have to look at it and then do it quickly, but that actually sums up to more time than doing it slowly. Then here, just do it like that. And then OLL and PLL, my biggest tips are, if you have something like just corners corners OLL, it's going to be easier to predict the PLL, because for example, for something like soon, if we have a block here, then that means we're going to get that means the block is going to be preserved if we don't break it in our first move. So for example, let's think of PLLs with blocks, a J-perm, and then do an anti-soon, a soon, and you'll see that here is a block. And if the first move of the soon is parallel or on the same side and doesn't break the block will stay preserved, and we know that the block will end up on this side. So we immediately know that the PLLs that have a full block are an F and J-perm. This case being a J-perm, we immediately go into the algorithm, set the cube down, and that's it. It's a good solve. Thanks for watching.